Now let us see one interesting root locus sum. Sketch the root locus for a unity feedback system whose open loop transfer function is g of s equal to k upon s multiplied by s plus 2, s square plus 2s plus 2. The open loop poles are 0, minus 2, comma, minus 1, plus or minus the roots of this are plus or minus j. So number of zeros are no zeros, and n equal to 4, m equal to 0. Therefore, number of branches equal to 4. All branches end at infinity. Therefore, the angle of asymptote phi a equal to plus or minus 2q plus 1 multiplied by 180 divided by n minus m equal to 4 minus 0 equal to 4. N minus m, that is 4. Q equal to 0, 1, 2, 3. 4 asymptotes we have to find. N minus m equal to 4. Therefore, Q equal to 0 means 180 divided by 4, that is 45 degree. Let us take the positive value. So 3 times 135, and Q equal to 1, 135 degree, and Q equal to 2, 5 times 225 degree. Then 7 times 315 degree. So these are the angles at which asymptotes approach the infinity. Now the asymptotes are meeting at centroid sigma a, that is equal to sum of real parts of poles minus sum of real parts of zeros divided by n minus m, that is 4. That is equal to minus 2, minus 1, minus 1. Minus 2, minus 1, minus 1. So that is divided by 4, that is equal to minus 1. So the centroid are meeting at minus 1. So here, now let us draw the root locus. Sigma j omega s plane 0, minus 1, minus 2, minus 3, and j plus j, 2j, 3j. This is minus j, minus 2j, minus 3j. So now we have to mark the poles. One pole at origin, another pole at minus 2, the third pole at minus 1 plus j, minus 1, minus j. These are the poles. Yeah, all points between 0 and minus 2 are part of root locus, because 2 it's right, odd number of poles, and zeros 2 it's right. Both are starting point. Therefore, definitely there will be a breakaway point. The breakaway point is we have to find breakaway point. We have to find k equal to minus of s plus 2, s square plus 2s plus 2. Okay. So what you will get? So s square, s cube, s power 4 plus 2s cube plus 2 s square. Then 2s, if you multiply by 2s, 2s cube, 2s cube plus 4s square, 4s square multiplied by 4s. So if you add all together, you will get s power 4 plus 4s cube plus 6s square plus 4s. Therefore, we have to find dk by ds, that is equal to 0. That is 4s cube plus 12s square plus 12s plus 4 equal to 0, or s cube plus 3s square plus 3s plus 1 equal to 0. This is obviously s plus 1 whole cube equal to 0. Therefore, s equal to -1, -1, -1. So the breakaway point is -1. From -1, they are breaking away. We have to find the angle of departure from this point. To find the angle of departure, angle of departure we have to find. Let us take here to find angle of departure 0. This is -2. This is -1 plus j. This is -1 minus j. So angle of departure from P1, P2, P4, P3. Let us find angle of departure from P4. Pi of P4 we have to find. So we have to find the angle made by line joining all these points. Obviously, this is 90 degree. This is 1. This is also 1. Because therefore this is 45. Therefore this angle is 135 degree. 135 degree. This angle is this is -2. This is 45 degree. 1 height 1. Therefore 45 degree. This is 90 degrees. Therefore phi net equal to because it is from poles. That's why -135 minus 45 minus 90 degree. If you add all, you will get the net angle is 0, 5, 270. 270 degree, minus 270 degree. Therefore, 5 P4 equal to 180 minus 270 plus minus 270, that is equal to minus 90 degree. So the angle of departure from P4 is minus 90 degree. Minus 90 degree. Therefore, for this, it is plus 90 degree. So the angle of departure phi P4 equal to minus 90 degree and phi P3 equal to plus 90 degree. So it come out at 90 degree, it going up at plus 90 degree. Now sigma A is -1, breakaway point equal to -1, sigma A also equal to -1. This is interesting. And now we have to find the point of intersection with the J omega axis. So now let us draw the asymptotes. One asymptote is at 45 degree. So it will go like this. Another one is -45. That is 315. That goes this way. Another one is 135, it goes this way. And another one is 225, that goes this way. So there are 4 asymptotes that also we found. They are cutting the imaginary axis at minus plus j and minus j. The asymptotes. These are all asymptotes. Asymptotes. This is also asymptotes. This is also asymptote. This is also asymptote. Now we have to find now we have to find the where it intersects, because one goes this way, another one goes this way, means definitely it will cross j omega axis. Where it cuts the j omega axis, that we have to find. For that, we have to take the characteristic polynomial from k. If you bring all one side, you will get the characteristic polynomial. That is s power 4 plus 4s cube plus 6s square plus 4s plus 4s plus k equal to 0. That is the characteristic polynomial, characteristic equation. How we got the characteristic equation? 1 plus g of s equal to 0. From that, we'll get the characteristic equation. So now let us find the the Root array. S power 4 s cube, that is 1 4 6 4 k. S square is 24 minus 4 20. 24 minus 4 20 divided by 4, that is equal to 5. Then k. S power 1 is this k will come here. S power 1 is 20 minus 4k. 20 minus 4k divided by 5. And s power 0 is k. So to find k max, we have to equate s power 1 rho equal to 0. Therefore, k max equal to, therefore, k 20 minus 4k equal to 0. Therefore, k max equal to 5. Substitute here in this row, a square row, substitute this in a square row. This implies s square plus 5s square plus 5 equal to 0, or s square equal to plus or minus 1, s equal to plus or minus j. Therefore, omega equal to 1. Omega equal to 1. So the root locus also cut at plus j and minus j. Therefore, the root locus branch and asymptotes are 1 over the other. Very interesting sum. The root locus branch and asymptotes are 1 over the other. That's all. So it's come down, it's going up. Suppose I want to find here, why it is 1 over the other? Because asymptote cut the j omega axis at plus j minus j. Root locus branch also cut at minus j plus j. The second reason is the breakaway point is minus 1 and sigma a also minus 1. That's why all are coincides. That's why the root locus branch and asymptotes are 1 over the other. Suppose you want to find you want to design a control system in which the zeta is equal to 0.7. Therefore, constant zeta line I have drawn. Its angle is 45.5 degree, because cos inverse of 0.7 equal to 45.5. So it cut at It cuts the root locus at A. It cuts the root locus at A. At A. From A, we have to draw lines from A to all poles. We have to measure the length from A to all poles. Suppose A is 0.5. Let us assume that A equal to, let us assume that A equal to 0.5 plus J 0.5. Let us assume. If we draw the real plot will be here. From there we can take. Yes. Suppose we are drawing the constant zeta line is going like this. The constant zeta line is going like this. That is zeta equal to 0.7. Constant zeta line. That is angle is cos inverse of 0.7. That is cos inverse of 0.7. That is 45.5. So now it cuts the root locus at A. The coordinates of A is 0.5, 0.5. Yes. The coordinate is 0.5 plus J 0.5. From there, we have to draw lines from A. This is A, point A. From there, we have to draw lines to all poles. This pole and this pole and this pole and this pole. So the angle, the length AP1, let it be P1, P2, this is P3, P3 and P4. This is P4. So modulus of AP1 equal to modulus of 0.5 minus 0.5 minus 0.5 minus 0.5 plus J 0.5, and P1 is 0. That's why for this we have to find the magnitude. That is equal to, you can call polar and minus 0.5 comma 0.5 you can pass, or you can find the square root of 0.5 square plus 0.5 square. That way also you can find AP1. Similarly, we have to find AP2. AP2 equal to modulus of AP2 equal to modulus of minus 0.5 plus J 0.5 minus, this coordinate is minus 2. That is plus 2 minus 0.5, 1.5. That is equal to modulus of 1.5 plus J 0.5. So you can call polar 1.5 comma 0.5, or you can find the square root of 1.5 square plus 0.5 square. That way you can find AP2. What is AP3? AP3 equal to modulus of 0.5 minus 0.5 plus J 0.5 minus the P3 is what are the poles? Minus 1 plus minus J. That is equal to minus 0.5, this plus 0.1, therefore it becomes plus 0.5. This is plus 0.5, J 0.5. This is also becomes plus J, therefore plus J 1.5. That is equal to polar magnitude of polar function of 0.5 comma 1.5, or you can find the square root of 0.5 square plus 1.5 square. That way you can find. That way you can find. Once you got all these values, the value of K equal to, let us write here, K equal to modulus of AP1 multiplied by AP2 modulus of AP3 upon no 0, that's why 1, So from that you can find the value of k at A. If you design the controller with k equal to this value, k equal to this value, you will get a zeta equal to 0.7. Zeta equal to 0.7 for your system.